evening. Welcome to Resource Stage, and thanks for coming. Thanks for coming, guys. Tonight we are talking about audio, and we are actually talking about core audio concepts, which is a little bit different than sometimes some of the things we talk about. So, for instance, a couple months ago we talked about microphones and different types of mics and how they work, that kind of stuff. And the next seminar in the seminar in February, we'll be talking about mixers, and we'll be discussing mixer concepts. So things like, we'll be talking about, how mixers are how you're expected to use different types of mixers and different components in mixers and that kind of thing. So that'll be an interesting evening. But tonight, Don Clausen, who has, if you know anything about Horizon, Don's been here forever. Close to forever anyway.
30 years.
30 years.
Almost 31.
Almost 31 years, okay. And Paul Vroom, who has not been here for 31 years, but has been here now in his second stint at Horizon now for a while. The two of them are going to talk about different types of audio concepts. And sometimes we all think, I think we posted this in kind of a little blurb about tonight, where sometimes we think, well, I got 2 ears and I've got a car stereo, so I know how audio works. And yeah, I suppose that might be true, but there's also some things about troubleshooting and things about how audio and how speaker systems and how different components, how they interact. And that's part of what the guys are going to talk about tonight. And they're going to kind of help to walk through some of those things. And I think it's going to be an interesting evening. So we're going to jump right into it. I'm hearing myself. I'm not sure where that's coming from. Does anybody else hear that? Oh, I'm streaming on my laptop out in the hallway. Okay, sorry about that. All right, that's my fault. All right, well, now that I've learned something about audio, I'm going to go deal with that. All right, so I'm going to turn this over to Paul and Don, and they will take it away. Thanks, guys.
Thanks, Carl.
Yeah, so we're gonna talk about some core audio concepts. We're gonna cover a number of different things. Let's click that. Basically, three different topics we want to cover, and we'll break those down a little bit more. We're going to be covering something about electronics. We're going to be talking about gain structure, how to set that up, why it's important. We'll be talking about some microphones. 2 months ago, Carl mentioned we did spend the entire evening talking about microphones, so we're not going to do an awful lot. We are going to talk a little bit about that right at the very end of the evening tonight. And then we want to talk about speakers. We've got a number of different speakers set up here, and we want to talk about, we're going to be talking about what the good aspects of some of these speakers and why we choose to use them, and a bunch of other things. So that's what we're going to cover tonight. If you guys have any questions, I don't know where the catch box is. Is it back there? We do have a catch box. So if you have a question, just raise your hand. We'll get that catch box to you, and you can talk into it. It's kind of important that you speak into the mic, because we've got some people online and they need to be able to hear what you're asking too. So we're going to dive right in and go from there. I think, Paul, you're taking it first.
Yeah, I believe so. Thank you. First thing we wanted to cover is gain structure, which is quite critical in any given audio system, especially in professional audio systems. We'll start here with the different types of signal levels that you can encounter in any given professional audio system. We have mic level, which is the quietest we have on this list, -50, quite quiet. Instrument level, -30, a little bit louder. Line level, which is what any mixer or professional outboard equipment would operate at. And consumer level, which we try to avoid, but it does happen from time to time. So what is gain structure? There's a couple of things we probably want to define first. One being the noise floor. So any given piece of electronic equipment, audio electronic equipment, is going to have a noise floor. It's going to have a operating level in which the components are going to make a certain amount of noise. And then any given piece of equipment is also going to have a distortion region. So that's the level at which the equipment cannot process the signal anymore and ends up distorting the signal. In between the noise floor and the distortion region is the operating level of that device. And for a line level piece of equipment, such as a mixer, +4, as we saw on the previous slide, is the nominal level. That's the ideal level. Now, as you probably know, most signals are not going to be a steady signal. They're going to have quite a dynamic range. So the idea is to get your signal in an ideal spot so that dynamic range is hovering around nominal. So why is this important? When each component of your audio system is receiving the optimal level, it's going to be operating optimally. So that has to do with your transformers, your capacitors, all the physical electronics inside are going to be happiest when it's receiving the level it wants. This will also lead to less perceived noise in a system and greater clarity. And I think I have a couple images here. Oh, we'll go here first. So some symptoms of poor gain structuring would be distortion, clipping, popping, what I mentioned before. Systematic level issues throughout the audio system. So what I mean by that is if your level is not correct coming into your mixer, all the devices after that are going to run into issues as well. So if your signal is too quiet, it's going to be too quiet once it gets to your stream or once it gets to your recording device. And all the various components in your audio system can suffer from poor gain structuring.
In the past, we've gone into some churches, and their complaint was their stream wasn't loud enough. The audio signal wasn't loud enough, and so we go in, and we would start looking at the system, and we would start. The first thing we would start at is with the microphone, the input gain, to make sure that that was loud enough, and Paul's going to talk that through in a minute. Make sure that that is coming in loud enough, and then throughout the entire gain structure, that everything is pushing it to its optimal +4 level, so that the stream could get a good level as well. Once we optimize the gain structure from the microphone input directly and then all the way through, that cleared up that the stream problem. Sometimes we had to dial back the amplifiers a little bit so that it wasn't too loud in the room, but that's totally acceptable to do in when you're setting up a system.
Absolutely, yeah. Thanks, Don. So yeah, and that's just one example of how this problem can become systemic. Streaming system, any element in the system can be affected by this. Of course, more perceived noise in a system and less clarity if your gain structuring is not set up properly. These images here kind of outline what I'm talking about. So in the first image here on the right, you have a nice hot signal coming in, kind of pictured in this little transient here, well above the noise floor. So you can hear the signal much louder than the noise floor. And if you need to turn down your signal, noise floor just goes down and your signal is still in a healthy zone. Image on the left, the transient is not very far above the noise floor, and if you need to turn up that signal in your mixer, you're bringing up the noise floor along with it. And now I'll do a demo. So if we get the overhead camera, start there. Check, check, check. All right. So we can see here on my meter, here's where I'm going to set my gain, or I'll use this meter to set my gain. So if I set that, so I'm getting approximately nominal level coming into the console.
And we know that because when Paul was setting it up there, he pressed the PFL button, which showed the input level on that meter that he's talking about.
Yes, thank you. Yes, I did brush right past that. Set my PFL. So now this meter is metering my microphone. And I'm getting a pretty healthy signal there. And what that means is that when my fader is at 0, I have room to come down, and room to come up, and room to mix this microphone in context of everything else. If I were to bring down my gain, so now we can see it's quite low on this meter. I have now limited my ability to mix this microphone to this range. And as I mentioned before, this problem can add up as it goes to the next piece of equipment, to the next piece of equipment. If we go to the opposite issue, too much signal coming into the microphone. Now I have the similar issue where I can only move my fader a small amount. So moral of the story is get the input right and you'll be able to operate the equipment as it's designed to. And we weren't really able to hear the noise because normally if your preamp is really low, we have the speaker quite quiet for what it's actually rated to do. But normally when your faders are up high like this, especially if you have quite a few faders up high like this, you're adding quite a bit of noise. We might be able to hear that on the stream end, but in here we can't really hear it too much.
So it's important to have the faders operated at or around the 0 mark, so that you've got the most control. You can move the fader a little bit and get a little bit of volume control. If the faders are down halfway, if you've got your gain up too high and your faders are down quite a ways, you move the fader a little bit and it's going to affect the sound quite a bit. That's because the faders are in a logarithmic design, and so that's what affects that.
And my microphone? There we go, thanks. As well as when the fader is at nominal, it is actually doing nothing to your signal, and it's just letting it pass straight through. If you're cutting or boosting, you are then affecting the signal, which is okay to a certain degree, but the main goal is to keep it closest to 0 and affect it the least amount, and you'll get the cleanest signal.
All right.
Yeah, I think that about covers it. That's kind of the real skinny of it.
That's the basics.
Yeah.
The core of it all.
Yeah.
So we're going to move on then?
Yeah, absolutely.
Okay, let's go back there.
Anybody have any questions?
I got one.
Yeah. Oh, we got a catch box there. Just speak into the X there.
Is this the microphone? Okay, cool. So it seems to me like there's a lot less room above 0 than there is below 0. That's by design?
That is by design, yes. In an audio console, in an audio system per se, if you've got a loudspeaker, you can only boost it so much before you run into feedback problems. And so you've got to be, so they don't give you that much, but you can certainly bring it down quite a bit and have that control. So that's why they put that at about the 3/4 of the way up.
And you mentioned as well, it's logarithmic.
That's
So
right.
The amount of change in the level from 0 to 10 on this mixer is going to be quite a bit more from -20 to -10. See those two numbers there? That's going to make a slight change in your level. That's going to make a massive change in your level. So as you go up, the change is logarithmic.
Does that help? Excellent. Any other questions? All right. Well, moving on then. We wanted to talk a little bit about cable architecture and why we use particular cables. Well, one of the things, there's basically two different types of cables that we use in an audio system, and that is balanced and unbalanced. The unbalanced cable is, no, I should talk about the balanced cable because that's what the diagram, there we go. We got two of them there. We got both of them there. The balanced cable is on the left with the two interconductors wrapped by the shield or the grounding. And that is the method that we use for microphones and for sending audio signals a long distance. We'll talk a little bit more about that as to why that is in a little bit. On the right-hand side there is the unbalanced cable, which has just the single conductor wrapped by a shield. And because of its architecture, it's much more susceptible to be picking up interference from outside, whether that's RF interference or EMI interference or other things. And so those cable lengths need to be kept fairly low. Another diagram here shows kind of a drawing of that with a shield wrapped around either the single interconductor on the unbalanced cable or the dual. So the maximum distance of an unbalanced cable is recommended to be only about 25 feet, because that's anything longer than that, you're very susceptible to be picking up some interference and causing noise in the audio path. The reason is because there's only the two conductors there, so if any interference comes in and noise, then it's very, very open to be picking that up. With a balanced cable, there we go. So the balanced cable has the two conductors wrapped by the shield. Both inner conductors are passing the same signal, but they're inverted to each other. So you notice that the top wire there has the audio signal going in a sine wave in positive direction, and then the bottom one has it in the negative direction, so that they're completely opposite to each other. At the far end, the equipment has a differential amplifier which looks at both of those conductors and says, okay, any signal that's in opposite polarity to each other, we're going to accept that and carry that on. If there's any other noise or any other signal that's part of that chain but is not in opposite polarity to each other, we're going to ignore that. We're going to strip that out of the signal. So it's way more quiet and a much better way of traveling, getting signals a long distance. With balanced cabling, we can actually travel thousands of feet and still get a good, clean signal. So we wanted to look at how do we tell if it's a balanced cable or an unbalanced cable. So if we pick up this cable and we pick up this cable, and I hide the ends here, they both look identical. They're both a rubberized cable, and you can't really tell the difference until you look at the ends, or you look at the conductors on the inside. This cable here, this is your unbalanced cable, 1/4-inch cable, or a phono cable. It's got the tip on the end and the sleeve. So we've got the inner conductor and then the shield. This would be used for plugging in a keyboard or a guitar or some other instrument generally. Again, keeping this length fairly short distance, less than 25 feet. This cable here, this is your standard XLR cable. So on the end, might be a little hard to see, but we've got the 3 pins on the end. Pin 1, 2, and 3. Pin 1 is the shield. Pin 2 and 3 are the signal carrying ones that are in opposite polarity to each other. So that is one example of a balanced cable, a balanced XLR cable. Another example is something like this. Whoops. So we've got the 1/4-inch connector on the end, but we've got a tip and a ring and a sleeve. Some people call this a stereo connector. Some people call it a tip ring sleeve, which is probably the better way of talking about it. If it's, it can be used to carry left, right, and a left and a right signal, but that makes this into an unbalanced cable because you've got the left on the tip or the right on the tip, however it's manufactured. The right is the ring, and then the sleeve is just the shielding around it, around both of those. So that becomes an unbalanced stereo cable. We use these in a balanced operation where we've got a tip ring sleeve connector, which is a balanced output going into a balanced input. So that's another way of dealing with that. You want to be careful when you say, oh, I've got this piece of equipment that has a stereo output, plug this into this, and then, oh, I'll just plug this into my 1/4-inch connector on the mixing console. That's not going to work very well because the left and the right are going to be, again, they're going to come into the mixing console and be connected to your differential amplifier, and it's going to sound really bad. We're going to talk about that a little bit more in a minute. Let's see, that would be this one here. So this particular cable, it's got the XLR male on one end and a tip ring sleeve mini or 3.5 millimeter connector on the other. Some people look at this and go, hey, I'm going to use this to plug in my phone into my mixing console. It'll work great. But you're going to run into problems, as I was talking about on that other cable, because this, your phone is sending a left and a right and the ground, and then this is your balanced input, which is going through the differential amplifier, and it's going to sound really, really bad. So that's not going to work to do that. We have this cable for another reason around the shop here, but definitely not that. Here's another example of a cable. We've got the XLR with the 3 pins. Then we have a tip sleeve or a mono connector here. Some people might say, hey, that's a perfect connector to plug in my guitar. I'm going to plug this into my guitar and plug that into my mixing console. It'll work great. But it won't. Again, because I don't know exactly how this cable is wired. I can't tell just by looking at it. I'd have to take it apart. But you're talking about an unbalanced signal at one end coming into a balanced input of the mixer, and it's just not going to work right. It's not going to sound right, and you could run into other problems. So that's not the way to plug the guitar in. So how would we do that?
Excuse me, Don.
Yes.
So I was just going to say, all of the cables and adapters that you've got there may be a way to wire them in such a way so that you will get some sort of reasonable sound. But it all depends. And just because you get it to work in one style of system doesn't mean it's going to work every time. And what we always talk about at Resource Station, what we always talk to our clients about, is the idea that we're trying to get consistency in how the system works. And consistency so that it doesn't matter who is touching the system, that when they plug it in, it works. So those cables that you have there that are from around our shop, we may have some very specific uses for those. And in some very specific applications, they may work perfectly to do even some of the things that Don mentioned. But you need to have A and B need to be exactly the right situation. So sometimes people will build adapters and they say, hey, I watched that seminar. It was on YouTube from the guys at Horizon. I did exactly what they said you don't do, and it worked. and you might be able to do that. But what we're shooting for is consistency for people to be able to get the same results every time and good results every time. Does that sound right?
Yeah.
Yeah, for sure. We do want to make things. We understand that in church environments, and I know some of you are in churches. You're not professional audio mixers. At least most churches don't have that, and so they got to know that if I use this cable, it's going to result in this way of doing things. This is a bad example because this is not the cable you want to use. So if you wanted to plug in, I think the next slide is direct boxes. Yes. So if you wanted to plug in a keyboard or a guitar, the best thing to do is to use a device called a direct box. We've got a number of them here. This is a Radial SB2 stage box. We've got 1/4-inch inputs on one side and an XLR on the other. This direct box, they are designed to convert the signal from high impedance input to a low impedance output. There's a transformer built in here, at least in passive ones, there's a transformer built in here. And so it does that. It also converts it from an unbalanced signal to the balanced signal so that we can run a long distance. And
it would also take that instrument level, going back to the slide showing the various level types, and drop it down to microphone level.
That's right.
So when you go into your microphone preamp, it's the exact level that it's looking for.
Mm-hmm. So there's a couple of other buttons on these direct boxes, on most direct boxes. On this end, there's a button that is labeled pad. So if you have an instrument that's coming in really, really loud, you can press that pad button and it drops down by about 20 dB so that it is at instrument level, and then it comes out microphone level out of the XLR. The other really, really handy button on this is the ground lift button on this end. And so if you plug in an instrument on one end and connect it to your microphone and you get a buzz or a hum or something, the first thing that you want to do is press your ground lift button on that particular instrument and see if it goes away. What that does is it breaks the shield or the grounding connection between the instrument and the mixer, and that will often solve that problem of a hum or a buzz. So we've got a number of different types of direct boxes here. We've got this one is the StageBug SB2. This is one of the lesser expensive boxes that we would recommend and sell. It sells for just over $100, but it's got a fairly good transformer inside it. It is a passive box, so it doesn't require any sort of external power. This one here is the Pro DI, which is a step up from that one. This is one that we generally often recommend for bass guitars because the transformer in here is bigger than the SB2, and it can handle those low frequencies fairly well and not distort or be overloaded. This has the same features as that one in terms of the buttons. This particular one, this is kind of a neat little one. It looks pretty much exactly like the Pro DI, except that it has a whole bunch of different types of inputs that you can come from. You can come from 1/4 inch inputs, RCA inputs. There's a tip ring sleeve input. So all of that can come into here, not at the same time. You can only plug in one different device in here. Otherwise you run into issues. And on the other side, there is an XLR input. This can be used as an isolation transformer if you've got something that's coming in balanced but causing buzzing or whatever. You can come in there and it'll go through there, and then the output to an XLR. This is a really, really handy Swiss Army knife for audio systems. And then we've got this J48. This is an active direct box, so it requires some sort of power. Normally, these days it'll come through the phantom power from the mixing console. Does everyone know what phantom power is? Yes. Okay. So that's handy. If you do press the ground lift switch, it is not going to cut off the phantom power. This thing will still keep working. On the older models, that would happen. So that was an issue that they've overcome. An active direct box and a passive direct box can be used in the same manner. This one has electronics in it that actually boosts the signal a little bit, so it can be used on instruments that don't have as loud an output, maybe an acoustic guitar, maybe a mandolin, or instruments like that, where you need to boost that a little bit more. This is the last direct box that we wanted to talk about. This has got a little cable on it with a tip ring sleeve. So this can be used to plug your computer in. You come out of your headphone jack with that into the StageBug, and then your XLR is coming out of there. It's got the pad on it and a ground lift switch. It also has a couple of 1/4 inch connectors, and this is where people get a little confused, because most direct boxes, a 1/4 inch is an input and the XLR is an output. Well, in this particular one, this cable is the input and the XLR is an output, and the 1/4 inch out is an output. So if you need to do some isolation going to a mixing console, the reason why they did that, there's a couple of reasons. One is this cable is coming in as a stereo connection, left and right. So the XLR, it does the mono sum to it. And so you might not want to be able to, or you might not want to sum both of those. And so that's where the two outputs here, they're actually labeled left and right. So you can continue that on, plug those into your 1/4 inch inputs of your mixer if you needed to, and do that. This is a very handy tool when you're connecting computers or direct boxes into your sound system. Again, we often run into hums and buzzes and a variety of different problems that come up, and this is a great little problem solver for doing that. Have I covered everything about direct boxes?
I think so.
Yeah.
The reason why we're always selling these and always putting them into systems is going back to gain structure and signal level types. You talked about laptops, you've talked about bass guitars, mandolins, keyboards, all these different things that you're going to be plugging into your system, all likely to have a wide variation of level. And what we're doing is isolating those signals, dropping them down to mic level to where the console wants them, and starting gain structure with the right foot. So DIs are very handy for that reason.
Excuse me, gentlemen.
yeah.
We have a question, or kind of a question, kind of a statement online. Somebody was asking about speaker cable, and is speaker cable unbalanced? Is it balanced? You can go a long distance, that kind of thing. So where does that fall in? And then I got another one. I got a follow up after that.
Okay. So a speaker cable is it is a tip sleeve like this one. It can have 1/4 inch connectors on it. These days, mostly it's speak-on connectors, which are a lot more robust. But they are a tip and a sleeve, or a inner conductor and or two conductors actually. They're usually a higher gauge than what this is. This will be maybe 22 gauge, maybe 20 gauge, whereas a speaker cable will be 14, 12, 10 gauge. So it's a lot thicker and a lot more robust. They should not be used, a speaker cable should not be used as an instrument cable to plug in your guitar, because this cable has that outer shield around the inner conductor, like we saw in the picture earlier. A speaker cable does not have that. It just has the two conductors, and they're usually twisted together inside another casing. Speaker cables can generally run longer than 25 feet. They can be run several hundred feet, depending on the gauge of the cable, how large the cable is, without interference. The reason why it can pick up or can run that far without interference is because it's running at a way higher signal than what this would be. This again is meant to plug in or to connect an instrument, which is at a very low level.
Very, very, very low.
After the mixer, it goes to a processor and then an amplifier, which boosts that signal significantly, and so it's not as susceptible to noise, at least not audible noise.
So then the follow-up question is, we use shielded wire for microphone cables, and we use shielding on unbalanced cables does Horizon install speaker wire with shielding, and if so, why, and if not, why not?
We don't install speaker wiring with shield on it. As I mentioned earlier, we don't really need that extra shield because it's running at such a loud signal out of that amplifier. It's pushing a lot of level, and so it doesn't need to have that shield. Does that sound right?
Yeah, there's a large enough difference between the level of noise that might be introduced versus the level of the signal traveling down the cable. It is not an audible issue.
Yeah, that's right. All right.
Thank you for the questions online.
On. Oh, I'm supposed to talk about this now too. Oh, I forgot about that. I thought we were going to a different section.
You thought it was your turn for a break.
I thought it was my turn for a break. So we can run into a lot of different problems with cabling, with balanced cabling particularly, unbalanced as well. But balanced cabling, we can have two different types of problems. One is a miswiring problem, and the other is a broken conductor. And what happens when you have either one of those problems? We're going to talk about miswiring first. So in this particular instance, you can see that the male is what plugs into the back of the mixer. The female connects to your microphone. The female end is actually wired correctly. Pin 1 is the shield. Pin 2 and 3 are the signal carrying conductors. But you notice at the male end, we've got the pin 1 is connected to one of the signal conductors, and pin 2 is the shield. So those two have been reversed. Using this cable, condenser mics will not work because the phantom power is not being sent down the proper conductors. It's not going to reach the microphone and work. Some dynamic microphones might work, but they might be prone to noise. So that is the male end is reversed on this one. On the next picture here, we see male and female again. The male end is wired correctly, but the female end is reversed. And this is going to result in exactly the same as the other one. A phantom power is not going to work. Phantom power is not going to get passed to the condenser microphone to work, but dynamic mics might work, but there might also be added noise. This next one is we see that it's electricians wiring. So they've wired the shield to pin 3 because that's where the ground is on your electrical plug, and pins 1 and 2 are wired to the signal conductors. So this is going to cause noise on the signal because between pins 2 and 3, the two conductors that are being used are not the same wire. It's really important in a balanced cable that the two signal carrying conductors that are in reverse polarity to each other are made of the same material so that the differential amplifier at the other end knows that it's working. In this case, it's not the same, and so it's going to cause some problem and some extra noise. This will work with dynamic and condenser mics, but it negates the benefits of the balanced cable. This one here, as I said, this is a total train wreck. They've got the shield on pin 3, and between pins 1 and 2, those are reversed in polarity to each other. It's just going to cause all sorts of problems. And And so that's where you shouldn't do that. I heard a story recently of a person who went to a store, not to Horizon, went to a store and bought a microphone cable, brought it home, plugged it into his mixer, and plugged in his condenser microphone, and the condenser mic did not work. And he's like, what in the wide world? He checked the fan and power, it was on, he checked everything. He tried a dynamic mic, and the dynamic mic worked. And he's like, well, this is really weird. So he plugged in the condenser mic again, still didn't work, switched cables, and the condenser mic worked. He's like, oh, this is really odd. He went back to the store, took the cable back to the store, and he said, this doesn't work. My condenser mic doesn't work with this cable. And the store owner said, well, you forgot to turn on the fan of power. And he's like, no, I tried that. I tried a different cable, and it worked. And so after doing a little bit of checking, they did test the cable, and they found it was wired incorrectly. I'm not sure how it was wired incorrectly, but it was wired incorrectly. They gave him a new cable, and away he was off and happy. So it's really, really important to test your cables. We have testers here. This is an example of a tester. And let me just get my mic cable out here and plug it in there and there, and we can test it. This particular tester, we can turn this little dial and we can see pins 1, 2, and 3 are all wired correctly, and so we know that this cable is correct and good to go. We can use this for any types of mic. This particular tester can be used for all sorts of different types of cables, from XLRs to 1/4 inch. We've got a 3.5 millimeter on here, BNC, RCA, and a Speak-On cable. So we can test all sorts of different things. There's all sorts of different testers that we can get. So if you want to get a cable tester, we can certainly talk to you about what kind would actually work for you. Let me go to this next one. Oh, okay. So this one shows what the correct wiring actually should be. We see pin 1 is the shield, and pins 2 and 3 are the conductors. The cabling that we often use for installs in particular, that is the actual color coding on the inner conductors, but it could be a number of different types of or colors. We wanted to do a little demonstration for you of what happens when conductors actually are broken. So we've got this little contraption set up here. We're gonna start with this particular microphone. This little contraption here, we've got green is the shielding, and then pin 2 and pin 3 are the conductors. So we've got that set up, and we'll just we used this already, so we know that it's actually working. This particular microphone is a dynamic microphone. It's an Audix OM3, and we really like this particular mic. It sounds pretty good, but it's a dynamic mic. It's a super cardioid pickup pattern, and it works pretty good. But what happens if we have a broken pin 1 or a shield? I'm just going to turn that off, take that off, turn that on, and oh, it sounds great. It sounds great. No change in sound whatsoever. With a dynamic microphone, this is going to broken pin 1 is not going to affect the sound. It might cause a little bit of noise problems, but it's in terms of audio quality, you probably wouldn't know. Now, what was going to happen if one of the other pins breaks or is broken, just put that one back, and I'll just disconnect this one and unmute that. And what now? I'm turning up the level here. Oh, I can hear a little bit. Yeah, there's a little bit there, but it certainly is a lot thinner and not nearly the level. I've got the faders up all the way on my mixing console, and there's only a little bit. So if you've got, and it's the same if you've got pin 2. It's a low volume and a thin sound. So if you ever plug in something and you have that problem, it's a good idea to test your cables and find out what it is. We'd done an install recently, and I discovered that on one of the microphone inputs. I had plugged in my my noise source into one of the inputs, and the system just sounded really, really thin, and couldn't quite figure out why it was sounding the way it was. And we did a little bit of investigation and discovered, one of the conductors hadn't been terminated properly. So we fixed that, and it was working just fine. So good idea to check that. Now, let's take this particular microphone. This is a Shure Beta 87A, which is a condenser microphone. And we're going to do the same test here. We'll unmute that. So all 3 conductors are working, and it's working just great. Sounding really good. If we disconnect pin 1, and then we unmute it, it's not working at all.
Nothing.
Nothing is there. Even if I turn up the faders, nothing is there. And that's because this is a condenser microphone, and so the phantom power is being sent down pin 1 to pin 2 and 3, and so the circuit isn't completed, so we don't have the power to do that. Back in September, we talked about microphones. We had a seminar on microphones, and we talked about the differences between condenser and dynamic. So if you need more information, you can always look that up. Now, what happens, I've got my faders back at 0 here, and I'm just going to disconnect pin 3 again, and then unmute it. And, oh boy, I think I've got to turn up my levels. They're all the way up again. And it's the same problem as the dynamic microphone. We've got a very thin sound, and it's very low in level. So we've got that problem there. And I'm not going to demonstrate this this problem by messing with some of the wires here like we were talking about earlier, because I don't want to make too much noise.
No? Oh, okay.
No, I don't. So that's so the short version is it's a good idea to keep testing your cables and finding out if something has gone wrong.
Well, if we can get the overhead mixer shot, and we're soloed on this microphone, if our ground is making a poor connection, look at that meter. That's definitely not what you want coming through your sound system. So if you're getting really loud crackles and you have a condenser microphone, that's what you're going to hear. Very, very loud crackles, which is what Don didn't want to expose us to.
I didn't want to expose them to. That's right. And even with a dynamic microphone, you could have problems, crackling problems like that if you've got a broken conductor. All right.
All right.
I think we're ready to move on.
All right. Well, that means
We'd covered that.
all right. We're going to get into loudspeakers next. I'm going to talk a bit about crossovers. So essentially what a crossover is the process of separating the audio signal into separate frequency ranges to target specific drivers or loudspeakers. So an example of this would be splitting up your audio signal, your output from your mix, to your top speakers, which this I would call a top, and your subwoofer. You can't see this online, but there's a subwoofer on the ground here. Here we have a QSC K2 series and a QSC KS112.
K-sub.
K-sub. The frequency range of this speaker is approximately 56 hertz to 20K. And the frequency range of the subwoofer is 41 to 108 hertz. So there's overlap between these two speakers without any crossover involved. So the idea with the crossover is using high-pass filters and low-pass filters, we can carve the sound so they're not overlapping. So here's a little diagram that kind of outlines this. And as you can see here as well, not all crossovers are made equal. There are different ways to approach doing a crossover. The red line here, the LR2, is a bit more of a slower slope. This here, by the way, would be the crossover frequency, the center where they would meet. So the slower slope results when the speakers combined, the overlap of the speakers, the teal line is flat. If you look at the blue line, we have the Butterworth crossover. Same crossover frequency, but it's steeper. And since it's steeper, it creates a 3 dB bump, which you see in the pink line there. And that's just kind of some real basics on crossovers, so 2 basic principles of approaching a crossover. So I'm going to do a little demo here. We can switch to Smart, please. Thank you, Logan. Oh, sorry, actually. My bad. Can we go back to the slide real quick? Sorry about that. I'm just going to outline what I'm going to do here in this demo. So I'm going to run pink noise, which is a signal generator that's equal energy across the whole frequency spectrum, to the top speaker. And then I'm going to put a high-pass filter on it to cut out any of the low end. Then I'm going to slowly introduce the subwoofer, and we're going to watch all this on a program called Smart with this measurement microphone right in front of the loudspeakers. And that's going to analyze the sound coming into this microphone out of these speakers. We can hop back over to Smart. Thanks, Logan. All right. I'm just going to turn off that one. Let me get a little noise here.
Are you on the right output?
Sorry. I did just test this before, so I'm just going to check one thing. My apologies. Okay.
Well, Paul is taking a look at that. The speakers that we've got here, these are QSC K10.2 2 speakers. They are a powered speaker. They're rated for 2,000 watts, but truth is that that's a certain amount of marketing exaggeration. They are a two-way box, so they have a horn and they have a 10-inch low-frequency driver. And then the subwoofer that's on the floor is QSC KS112, which is a single 12-inch subwoofer as well. That is the subwoofer that's there, right?
Yes.
Okay,
that's the
great.
one.
Okay, thank you.
Thanks, Carl. Yeah, sorry about that. But this gives us a chance to at least look at this. So this is what this microphone is reading off of this speaker. I'm going to engage a high-pass filter, and we should see some of the low end taper off here. Just double check I got that right before I start. Okay, so we saw some of that low end drop off there, and now I'm going to bring in this subwoofer. Now we can see there is a little bit of a gap the way I have the crossover working right now between the two speakers. But if I disengage this high pass filter, let's just watch what happens. So it's not happy. The overlap between the two speakers can be unpredictable, especially when you just throw a couple speakers up like this. So the idea with the crossover is to clean that up, have the gradual crossover from one speaker to the next be smooth across the frequency spectrum. And that's really the idea of what we're trying to do with a crossover.
One of the things we wanted to mention as well, Paul was doing the demonstration of the crossover with the mixing console. Normally, in all circumstances, we would not use a mixing console for this. We would use a separate digital signal processor to actually look after that crossover region, equalization, and optimizing the loudspeakers for the room, for the space. And then the mixer can do what it does best, and that is mixing audio signals. And the processor looks after the crossover, and people don't touch that to mess with that.
It's really the main benefit is if you were to do your crossover on the mixer like this, you could derail the whole tuning of the system with one button.
That's right.
Which, we want to avoid.
At the risk of sounding like a sales pitch for Horizon, this is a large portion of what we do for people is we install systems and then properly tune them. And the smart software and the microphones that Paul and Don are using tonight are part of the rig that we use to do just that. And we'll use multiple microphones in a room to make sure that we're setting things like crossover to make sure that that the entire system is designed properly to work together. We also typically wouldn't leave a speaker system looking quite like the jagged line that you see there on the display. Usually we would do something to try to even that out a little bit. But for tonight's demonstration, that helps to exaggerate the situation.
Yes, that's a good thing to point out. None of the demonstrations that we're doing tonight we're going to show an optimal situation. We're just showing various theories.
what can happen, what problems can crop up if you do things in a wrong way.
I think that's it for crossover.
Okay. So if we can go back to the PowerPoint, there we go. And what's next? Loudspeakers, subcardioid loudspeakers. So one of the things that loudspeaker manufacturers have been having to deal with for many years is there's a problem where low frequencies tend to be more omnidirectional than high frequencies. High frequencies, loudspeaker manufacturers have created horns to try and direct that in certain directions, in certain ways, and to control that. Low frequencies have been very difficult to do because of their long wavelengths. They tend to go everywhere and come off the back of the cabinet. And so in conventional loudspeakers, as this says, as the loudspeakers become progressively less directional with decreasing frequency. So as it gets lower in frequency, there's more sound coming off of all of the different sides of the cabinet. And so they've designed a couple of different ways of doing it, of dealing with that. And one of those methods is to add another loudspeaker behind the first loudspeaker, and then you use delay and playing with the levels a little bit, and polarity reversal, and you can create a cardioid sub array with two loudspeakers, one behind the other. It takes a fair bit to get them set up. You need to be very specific in your distances between, and then it also requires the extra speaker, the extra amplifier, more processing. There's a lot to it to get that set up. And it works quite impressively, but it requires a large footprint and a lot of equipment. So Fulcrum Acoustic has worked on a solution that will deal with that and not have to deal with that. Now I want to tell you a little bit about Fulcrum Acoustic. This is a loudspeaker manufacturer company out of the States, out of Massachusetts, I think it is. And they started about 16 years ago, I think it is. The fellow that was behind is the chief engineer there. His name is Dave Gunnis. And he originally started out working for Electro Voice. And then he went on to EAW. And then about 16 years ago, he said, I really want to start this company. And so he and a few others, they got together and they formed Fulcrum Acoustic. And he started creating loudspeakers. This is an example of one of them. We're going to talk about this one in just a little bit. But the first one that he created looked exactly like this, only it was a standard conventional loudspeaker, the CX12 loudspeaker. Really compact. It's got a 12-inch woofer in it, and then a coaxially mounted high-frequency driver right in the front. That driver is the high-frequency driver is available in a number of different dispersion patterns. This particular one is 90-degree horizontal and 45-degree vertical. One of the neat things about having a coaxial mounted loudspeaker or driver in there is that it's fully rotatable. And so if we, as a designer, we say, well, we really don't want to have 90 degrees horizontally. We want to have 90 degrees vertically for whatever reason. There's a number of different reasons. So we can take that that entire driver assembly and rotate it 90 degrees and have it rotated so that the 90 degrees is this way. The other neat thing with this particular cabinet and the coaxial thing is we don't have to choose 90 degrees rotation. We can actually go 45 degrees. That sounds a little weird, but we've actually come into a number of different applications where that particular being able to rotate at 45 degrees has actually been really, really beneficial for the particular installations that we were working on. So this particular loudspeaker has been really, really good. They've got a number of other different models that are available that are a little bit larger and quite a bit larger. They all follow this very similar pattern. Then a few years ago, all of those loudspeakers were the conventional loudspeakers. They had a lot of sound coming off the back and potential problems acoustically related to that. Then Dave Gunnis decided or began working on another solution. And if we go to the next slide, and he came up with this subcardioid cabinet with a single passive cardioid speaker powered by a single amplifier, and the low frequency off the back of this loudspeaker is about 9 or 10 dB lower than what's coming off the front. We're going to listen to that in a minute. But the way that he did this, if I rotate this way, you can kind of see there's some vents here. There's also vents on the other side of that. And then the interior of it is designed in such a way to channel the sound so that there's some nulls and some inverting of the sound coming off of this, which really is quite impressive. So what we're going to do is we're going to play some. Let's play the bandpass.
Yes, so this is a bandpass pink noise. So basically it's the same pink noise as before, but there's a bandpass filter centered around the low end. So what we're hearing off the speaker is low frequency that will typically travel omnidirectional from the speaker.
And then I'm gonna turn this around and you can listen to the back end and see how impressive this actually does sound. Oh, wrong speaker.
Whoopsies.
So you could hear that significant drop off in level from that. Oh, we were going to show Smart. I see Logan had it up on the screen there. Oh, we did do that. Did we actually see the results on there? Okay. I was turning the speaker. I wasn't watching there. So yeah, so we could see the different results.
Do we need to show that again? Or? No? Okay. Bit slower?
Okay.
Yeah?
Sure.
Should probably time it to that speaker to get it accurate.
Oh, it's low frequency. It doesn't matter.
Yes. Good point. Good point.
So you could see that significant drop off of the low frequency, and you could hear it as well. So it's been a very, very practical loudspeaker to use. I was listening to Dave Gunnis talk about the subcardioid design, and he had the first year that they brought this to a trade show, they were talking to people, and they were talking about, well, where would something like this be beneficial? And they were thinking, well, if it's close to a wall, if it's mounted close to a wall, then it's cutting down on the reflections off of the wall, which can degrade the audio quality. If it's in a delay setting where you've got a main speaker here, and then halfway back in the room you've got another loudspeaker. If you use the subcardioid loudspeaker here, then you're cutting down on the low frequency that might be hitting the people that are sitting in front, on the stage side of that speaker. Is that in front or behind? So he thought of a number of different reasons, and he said by the end of the trade show, people were coming up to him and basically said, "Is there any time where you wouldn't want to have a subcardioid cabinet? Is there any time where having low frequency sound coming off the back of the cabinet is beneficial?" There really isn't. So we at Horizon, we've started using these particular these speakers in a number of different applications with some really great success. Fulcrum Acoustic also has subwoofers that are cardioid patterns. We have some in our rentals where it's a single 18-inch driver and 9 or 10 dB drop off of low frequency off the back end. Really impressive to work with.
Yeah, you might notice Don's excitement as he talks about this, but it actually is quite groundbreaking technology in speaker design. It's exciting to have this to work with now.
I think sometimes we get really excited about it, but at the practical level, if you're trying to talk to somebody and say, hey, our theater, our church, our school should be buying this speaker over something else, it can come down to two things. One, if you're using a speaker like this that has less sound coming out the back end of it, then you're going to have less potential for feedback. And two, if there's less sound coming out of the back end, and as Don has already mentioned a couple of times, the sound is not reflecting off of the back of a wall or back of something else, then you are getting the most direct sound coming out the front to people. Therefore, it's going to be the cleanest sound. Those two things, clean sound and best chance to avoid feedback, those two things alone really sell this speaker, not only from our perspective, but from the people that we're talking to, and when they're going to their board of directors or committees or whoever to say, we should spend a couple of more dollars on this. And it really is just a couple more dollars. It's not a lot more, but it's worthwhile to go to this kind of technology. It does make a difference.
Mm-hmm. Thank you. I think that's it for that.
We should get moving along here. Could we get the PowerPoint? Thank you very much. I believe we're going to start talking about incorporating more than one loudspeaker into a space, which is the majority of systems that we install and work with. Yeah.
So when I endeavored to start a design of a loudspeaker system for a room, one of the things that I specifically look at is how to cover each seating section with one loudspeaker. I want to avoid having multiple loudspeakers. We're going to talk about that and actually look at that in just a little bit. But we want to do that so that any overlap, if we do have to use more than one loudspeaker, that there is overlap in an aisle or someplace where people are not actually seated. But we wanted to demonstrate that.
Using these K10 speakers as well, which
that's right.
I believe you were going to talk about the dispersion of these.
Oh yeah, so we talked about these. These are powered loudspeakers. We have two speakers set up side by side. Each one of these loudspeakers is a 90-degree conical dispersion pattern, so it's 90 degrees in all directions. So sitting side by side like this, if we turn on both of these loudspeakers, we're going to get a significant overlap between the two. And what problems is that going to bring up? We're going to be able to see that graphically on the Smart in a bit.
Yes. Should we do that now?
I think so.
Yeah, okay. So we have this measurement microphone, which we used before in the crossover demonstration. Right at the back of the room here, we have a second measurement microphone that we're also going to look at, and it's going to help demonstrate how different the sound is going to be depending on where you're sitting.
Yeah, so we've got this microphone here. It's very close to here. We don't usually do this close, but it's somewhat in the center of these two loudspeakers. That one is a little bit off axis to what these are. So let's show them what. So we're going to look at Smart again, and we're going to look at one loudspeaker to begin with, and then we're going to turn on the second loudspeaker.
And for people who are joining us on streaming, what we'll do is we have this microphone here that's going to, for you to hear what's happening with the speakers. We're going to pick it up and move it just so you can hear the sound change as we move it across. And we'll start with just one loudspeaker. Second.
Let's pause that. Just pause it for a little bit. So what we're looking at on the Smart screen here is the green line is this close microphone here. The blue line is the one that's at the back. The reason why they're distance is because we wanted to be able to show you the difference between the two between those two locations. Where the we see it on the blue line where it sometimes disappears.
I think that's because it picked up your talking.
Did it pick up my talking?
Yeah, got confused.
That happens when there's what's called low coherency. So the Smart software is pretty smart, in that it recognizes it's comparing a direct signal from the mixing console and what's coming in on the microphone, and it's comparing that. And if it's not looking very accurate, then it's going to say this is low coherency, and it's not going to actually show you the results. So that's why there's some black lines in the blue section there. But we can see that between these two microphones, that the frequency response is it's relatively similar. There are some differences.
Bit of a spot here, but yeah, it follows the general same trajectory.
Yeah. So if we turn on and online, we move that microphone back and forth. It's a fairly even sound as we move it back and forth. So let's turn on the sound again for both loudspeakers.
Mm-hmm.
And I'm going to pick up and move this microphone as well, and so that the people online can listen to that as well.
Yes, and online just listen for how the sound changes as Don moves the microphone on and off axis.
Yes.
Can you stand in front of the table because you're actually blocking the speakers where you're standing?
I can do that.
Don's a big guy. All right, so I'm going to turn on one speaker and then the second.
So then on this Smart display, we noticed a significant change in levels, particularly on This particular mic at about 3.5K there's a significant null, and then again up at about 10K. But then the blue mic is way different, with some nulls at different locations and some boosts. At the 3.5K, it's actually boosted at that particular frequency. So what this is showing is when we've got both of these loudspeakers both covering the same area, as you the frequencies, some frequencies will be boosted and some will be cut. And it depends on where you are. And if the people here in the room would have moved around, you would have heard some significant changes in sound as you moved side to side. The location of these two microphones is actually shows it fairly evidently. Mm-hmm. And so when we design a loudspeaker system, we will always try to avoid that overlap. And so we would like take this loudspeaker and do it at 45 and take that at 45 or so, something like that, so that the overlap is in the center here, but each loudspeaker is covering each side. Did we want to show that?
Sure.
I'll just go down out of the way again. Okay. So we see on here that there is still this significant null on this mic at 3K. That's probably because there's still some overlap in here between the loudspeakers. I just eyeballed them. When we design a system, we actually look at angles very particularly to know that exactly it's going, but it does look quite a bit different than it did when they were facing side by side. What else did we want to say about this?
I guess all this is just important in that we're normally installing more than one loudspeaker, and as you said, we're carefully calculating the angles and interaction between these speakers to get a flat response and even level across the seated area is the goal. We're kind of showing you very non-optimal situations that we might run into, but this just to show you what can happen between multiple speakers in a room.
Mm-hmm. Any questions? Okay. Moving on.
Okay, yeah, moving on.
What's next?
How are we doing on time? Okay.
Oh, were we going to talk about this?
This is, Don and I were talking about this before because it could lead into its own seminar.
We use delay. When we talk about delay, what we're talking about is actually delaying the audio sound going to a particular loudspeaker. We use that in a good example is where we've got a fairly long room. We've got one loudspeaker up near the front covering the front half of the room, and then another speaker towards the back covering the back half of the room. And so it's really important, if we didn't put any delay in, then anybody sitting close to the second speaker or in the coverage pattern of the second speaker, they would hear the sound from the first speaker or from the speaker closest to them, and then a few milliseconds later they would hear sound from the front speaker. and that would cause some significant intelligibility problems and cause people to it's not a pleasant thing to listen to.
Very similar to the issue that we outlined previously with the two speakers overlapping. It's the same.
You'd have different frequency responses, and it would just sound very very confusing. So what we do is the delay, what we call the delay loudspeaker, the speaker that's at towards the back of the auditorium, we will physically delay that in time so that the sound emanates from it after the first one, so that anybody sitting in the back, it actually sounds as if the sound is coming from the front loudspeaker. It's a really cool, it's really neat to actually sit there and play with the delay, and while you're sitting there listening, and be able to get that to be the optimal setting for that. And it's a really important thing to do. We can certainly do that on a digital mixing console. It's got some delay built into it. We don't recommend that. We recommend that all gets done in that signal system processor, so that it is all locked away and it can't be messed up with by the average user. I don't know. Do we want to show this? We did talk about it. We can do that.
Yeah, we can certainly show it. We were also talking about delay between two speakers right beside each other.
Oh, the delays, yes. So sometimes when we get into installations where we have two loudspeakers in close proximity to each other, covering the different sides, and say there's a center seating section, and we just can't avoid not having the overlap in that seating section, which causes this destructive interference. And so we've devised a method, or we've come across a method that actually works fairly good, where we'll take one of the loudspeakers and we'll delay it just a little bit, not a whole lot. People in the audience don't recognize that there is a delay happening, but it really helps to smooth out that overlap area, and it works really quite efficiently.
Especially in the higher frequencies that travel much faster, or not faster, but at shorter distances.
Yeah.
So the slight delay, even though it's very small, for the higher frequencies, it arrives at your ear at distinct different times, but your brain doesn't process it as that. It processes it as one arrival time.
So we can demonstrate that with these two loudspeakers here. It's a crude demonstration.
Yes,
but
emphasis on crude, yes.
But we can certainly show that. I think you can.
And you have the delay set right here.
To
8
8.
notes. Yeah. Okay.
So we've got one of these loudspeakers. I think it's this one here. It's set to 8 milliseconds, or is that the other one?
It's this one here.
It's that one there. It's set to about 8 milliseconds. We're gonna show. We're gonna play sound out of both of the loudspeakers without a delay, and then we're gonna introduce the delay. We're going to leave this microphone stationary for this demonstration because it is fairly evident even online with it just stationary.
All right.
You did the wrong one. There we go. So take it out again. Take it out.
Take the. Oh, sorry. Yeah.
So you can hear a significant change in sound. We didn't do anything except we introduced an 8 millisecond delay on the one loudspeaker. And that helps to, with listening as well as with smart, we can really see really evening out of sound. So it's one of the other things that we do as when we're setting up a system that we take into account, just to make sure that it's optimized in the room. I think that's it.
I think that's it. I don't think we have time to cover the microphone bit. That would probably take 10 minutes. I think we're over.
One of the things that we did 2 months ago at the microphones resource stage, we had a microphone set up out in the outside the room, and we were listening to the polar pattern. We actually rotated a microphone while a person was speaking to be able to demonstrate that. Quite a number of years ago, we set up a demonstration where we had a microphone on a turntable, and we videotaped it and watched it turn and listened to the results. That was many years ago. It was in the old 4x3 format, and it was a rather a crude setup. So we decided we were going to redo those videos. And last week, Paul worked on redoing them, and so we've got a new set of these videos. It's very similar to what it was, but we now have Smart up in the corner, and we'll be posting those online so that you can actually listen to them and watch them, see them in action. We were going to show them tonight, but I think we're running out of time. So I think that's it.
Believe so. Questions?
No questions.
No questions at all.
Overloaded?
I have one question. I'm going to throw something at you guys that I don't think we have a demo set up for, but I'm wondering if we might, how hard it would be able to do. Do we have the ability to throw one of these speakers out of phase with the other one?
Polarity?
Yeah. We can do that on the input, but we can't do that on the output on the console, right?
I don't think so.
So, but we could.
Yes, you can.
We can.
Yes.
You can flip the output.
Yep.
Okay. Can we do that and show what that looks like?
Absolutely.
Because that's kind of an interest. That's another interesting.
That's a fun experiment.
It's a fun experiment that we'll end off the night on a fun experiment.
So what we're doing here, what we're going to do is we're going to take one of these loudspeakers and we're going to flip the polarity on it so that it is 180 degrees out of polarity from the first one.
So one speaker moves out, the other moves in.
And we're going to see what happens when these two loudspeakers sitting side by side are going to do that.
So if we can just bring up one speaker and then bring up the second one and flip it, then
Flip it after bringing it up? Or...
surprise us.
All right. All right, let's see which one I've done here. You can guess. It's probably really hard to guess what I did there.
Can we actually? It was pretty quick. Can we see what happened there on?
Yes,
on Smart?
absolutely. So I will start with it off.
With just one speaker?
Sorry, with the polarity not flipped on either speaker.
And both speakers are on?
Both speakers on, yes.
Okay.
You can see it works a lot better on the low end. Which makes sense.
Yeah, This is kind of an interesting thing. So, in a number of the stuff that you guys have talked about tonight, we have had phone calls from customers, and they'll call us out and they'll say there's something wrong with our speaker system, or they'll call us out and they'll say there's something wrong with our microphones. We need to replace our microphones. And you can tell that that polarity flip that was done on the console can be just two wires mixed up on the cable, right? And that could be two wires mixed up on the cable going from the mixer to the processor, from the processor to the amplifier, from the amplifier to the speaker, or it could be the wires inside the speaker that are flipped. It could be any of those pieces along the chain. And we've had that. We've had actually way more than once, where somebody will say there's something wrong with my device, and at the end of the day, there's nothing wrong with your device, it's cabling. We actually went to a client, this is going back a couple of years now, probably about 6 years ago now, and they were having problems with their subwoofers. We were trying to figure out what was going on with their subs, and it just didn't make sense. And they had double 18 subwoofers in a room that was maybe 4 times the size of this room, and these double 18s just didn't get enough output out of them. And so and one of them was blown. And so our guys got up to them and they pulled out the speakers, and as they're pulling them out, they of course have to disconnect the lines going to the driver. And one driver was wired one way and one driver was wired the other way. And so the subwoofer was going back and forth, fighting against itself through the entire time. And, little things like that can destroy sound systems really quick, because if you're trying, as Paul was just pointing out, we're seeing on Smart how it's cutting out that low frequency. Well, if you're thinking, wait a minute, where's all my low frequency? You just keep pushing it. Well, the speakers are still producing that sound. We're not hearing it with our ears. The microphone is not picking it up, but that sound is still being produced by the speaker. And so if we keep pushing, you can blow up that driver. It's not that, that measurement is being taken at the microphone. It's not being taken at the speaker. Am I making that clear? I just want to make sure that everybody understands that we heard something happen dramatic there, and we're seeing something dramatic happen on the screen. But that's not the reality of what's happening with the speakers. They're still moving, right? They're still producing sound. And so you can blow up a speaker pretty quickly with just having two wires flipped. And we've got those phone calls. Or again, like people calling us saying our microphone is bad. And Don showed that quite well, that if it's just one pin off. And it's funny, some of our clients in older buildings, older churches, older community theaters, those microphones just aren't working anymore. But we also seem to have a lot more mice around lately. Or squirrels, right? Or in the case of Metropolitan United, maybe a couple of
pigeons.
I think Mark bats. Yeah, I think Mark is still scarred from a couple of weeks ago up in the attic there. So yeah, it could be a variety of different things. All right. So is there anything else that we need to make sure that we talk about tonight?
Did we need to talk about the prize?
Oh
yeah, the prize. Yeah, that's right. So for September, October, and tonight we have the friends at Shure have sponsored by helping us out with some door prizes, and so we gave away a pair of headphones and we gave away a USB microphone, and tonight we're giving away a pair of ES215s, which can work great if you're just gonna listen to your favorite podcast, or they'll also work great if you want to use them as in-ear monitors.
My AC broke in my vehicle, so I drive with the windows down and nose in. It's very quiet and comfortable.
Right, because they're not noise canceling headphones. They are sound isolating earbuds.
Yes.
So yes, that is different. Yes, I didn't ever think of them as a solution to your air conditioning breaking, but yes, I suppose that is
Creative solutions.
That
there.
was great. Yeah,
Whatever
there's
works.
a bonus. There's a bonus that I didn't think that we were gonna cover tonight. Okay, so on the screen there is a. If you are on the stream, there's a QR code there, and I believe that what Matthew has been saying is that we are running the contest until 8 p.m. on Wednesday evening. So if you are here tonight, you will be entered into that draw. And if you're online, if you want to enter into the draw, then you can scan that QR code and fill out the information there. And yeah, we had somebody, the first month we had somebody winning who was here. The second month we had somebody winning who was watching online down in Dunnville?
Could be. I'm
Dunnville.
not sure.
I think it was Dunnville. All right. Well, thank you very much for coming tonight. If you've got any questions, then please let us know. You can stick around for a couple minutes and ask. You can always find us here at Horizon. And yeah, and if we will definitely, this video is posted online. I know a couple of people have asked already tonight whether or not this will be available if you want to go back and take a look at anything. And also we will be posting those videos. I think the very first videos, Paul was mentioning the other day that he actually helped record those ones when he had less facial hair. And I think they actually, Don said we videotaped them. I think they literally were on tape. I don't.
I think
they
so.
might have
yeah.
been. I think they may have been. So yeah, you can find those there, and they're really a great resource if you're trying to talk to somebody about how microphones work and what different pickup patterns are like, and that kind of thing. So thank you very much. We will not have a resource stage seminar in December. We will be back in January. In January, we were going to be talking about lighting control concepts. So that's a very different sort of thing than what we're talking about tonight. We are not going to be looking at one specific lighting console. We are going to be looking at how lighting control consoles work in the modern age and some of the ideas that are being implemented by different manufacturers to get from the idea I have for what lighting should look like to how do I make it happen. And that will, some of the ideas that we're talking about will fit for a variety of different types of lighting control consoles and that sort of thing. And then in February, we're talking about audio consoles, and in a similar sort of way, we'll be talking about digital audio consoles and the concepts that fit between for different types. We will probably be looking more specifically at the Allen & Heath SQ series because it's the #1 selling console for us right now, and we will be looking at how that transfers up to consoles like the Avantis and bigger consoles than that, maybe even some of the digital consoles, and down towards some of the Q consoles and that sort of thing. So it's all over. And then we'll be going on from there in March. If you are a teacher or an educator and you are interested in checking out the series of seminars that we do on the last Tuesday of the month, then you can do that, or anybody can check them out too if you'd like. They are short sessions that Matthew and I do. Last month we talked about black lights, and we had bottle of Tide, and we had some black light paint, and it was a little weird. But that was last month. This month, I believe we're talking about miking a choir. Does that sound right? Anybody at the back? Yes. All right. So if anybody wants to come and be our choir, then we will be doing that on the last Tuesday of the month. Thank you very much for joining us. Thank you very much, Don and Paul. I feel I'm sitting at the back there tonight, and I'm thinking, we're actually really fortunate at Horizon to have the variety of people that we have here, and with kind of the background of knowledge that they've got. Because Don's background is very, very different than Paul's background, is very different than Logan's and Mark's and Vadim's and all the other people at Horizon. And it works out really, really well. We're able to provide people with solutions that are coming from different perspectives. And I don't think that's really just a tagline we stick on our social media. I think that's actually true. Thank you very much for coming out tonight, and we hope to see you in January.